Hi friends, today we are going to see on the topic scales and sludges in boilers. This is Dr. S. Rekha, Associate Professor, RMD Engineering College, Chennai. Water is mostly used for industries. Water plays a vital role in industrial usage. It is mainly used for the production of steam and as a coolant in especially nuclear industry. Steam is also used for producing electricity. Water which we are using for industry has its own requirement. What are the requirement of a boiler feed water? The water which is fed into boiler for the production of steam is called boiler feed water. Now let us see what are the requirement of a boiler feed water. The water which we use for boilers should be free from calcium and magnesium salt, that is hardness causing salt, and it must be free from dissolved gases like oxygen, carbon dioxide, which may cause corrosion to the parts of the boilers. It should be free from suspended impurities which may disturb in working of the boilers. It also should be free from other dissolved salts and alkalinity, and it should be free from oils and turbidity. Oils and turbidity may cause priming and foaming in boilers. So water fed to the boilers should be free from all these impurities like calcium, magnesium, or gases, suspended impurities, dissolved salts, oils and turbidity. If the water which we are using in boilers does not meet out the need, then what are the troubles caused in the boilers? It causes major 4 troubles in boilers. First is sludge and scale formation in the boilers. Then priming and foaming in the boilers, leading to caustic embrittlement of the boiler parts and also leading to boiler corrosion in the boiler parts. Types of boilers. Various types of boilers are available in the industry based on pressure. Mainly these boilers are considered, that is having high pressure boiler, medium pressure boiler and low pressure boiler. Based on circulation of gases, it can be fire tube, water tube boilers. Based on position of shell and axis, vertical axis and horizontal axis boiler. I'll show pictures of these so that you can understand better. See, this is the first one is the modern boiler generator. It's a small type of miniature of a boiler, and we talked about vertical boiler. Vertical boilers were used in the ancient days, that is olden days, when the boiler was designed. It was used in the vertical form, but nowadays it is used in the horizontal form. And we were talking about water tube boilers. That's the picture here, and fire tube boilers here. Yeah, this is the real industrial part of boilers. See, an array of boilers are there for production of steam, for continuous production of electricity maybe, or for major activity in the industry. See the first picture, industrial boiler, how it look like. Really it is engineering, right? It gives you a lot of engineering in it. Yeah, then it is high pressure boiler. The look of an high pressure boiler here. A high pressure boiler has more risk than the low pressure or medium pressure boilers, and it should have more safety measures. So this is the cutaway view of the boilers, how the boilers will be inside. See here, the yellow flame is the fire which is used for heating the boilers, and we have the tubes, channels for the passage of steam through it. So this is the view of a boiler, beautifully shown here. Now, in boilers we have 4 troubles, but here today we are going to cover only one topic, that is sludges and scale formation in the boilers due to hardness in the sludges. Sludges is the soft, slimy precipitate, white precipitate formed inside the boiler. So here you see the black spots. So these are the precipitate which is floating in the boilers. So how this is formed? As you take the salted water and you start boiling it, only the steam is carried away, that is water vapor H2O alone is traveled. We know very well that on evaporation of water, salt is left behind and water alone gets evaporated. So here in steam production, water alone is evaporated, leaving behind the salt. As we continuously evaporate the water, what happens is the concentration of the salt in the water starts increasing. As time goes off, the salt concentration crosses its saturation level at the given temperature. Once it crosses its saturation level, the salt is thrown out as a precipitate inside the water, boiler water, and it starts floating in the water. And these are found in the generally on the colder portion of the boilers, and where the flow rate is lower, they start slowly collecting at that part. These sludges are formed mainly because of magnesium carbonate, magnesium chloride, calcium chloride and magnesium sulfate salts. What is the disadvantage of sludges in the boilers? They are poor conductor of heat. So if sludges is floating in the boilers, we have to supply more heat for the steam to be produced and to maintain the given pressure. It means wastage of fuel occurs. And I told no, the precipitate starts collecting at the colder portion and where the flow rate is very low. So what happens slowly? It starts choking the pipelines through which the steam is passing through. So what happens now when it starts choking the pipeline? You know, when a pipeline is choked, what happens to the pressure? Yeah, pressure is increased. So in boilers, we have to maintain a given pressure. It cannot decrease or it cannot increase also. So by choking the pipeline, it starts disturbing in the working of the boilers itself. And also one more major problem, sludge and scale. The next topic we are going to see is scale. These two occur together in the boilers, and sludge, what happens, this precipitate, when scale is deposited, sludge is entrapped and deposited as scale. Sludge turning into scale. Scale is more problematic for boilers than sludge. So sludge is entrapped by the scale for deposition and deposit as scale, and it causes major problem to the boilers. See the view of the choking of the pipeline here. In both the figures, you can see how the precipitate starts choking the pipeline and disturbs in the working of it. So pressure automatically increases. So we have to reduce the fuel level so that the pressure is maintained properly. Otherwise, it turns into, creates a lot of problems in the industrial. Now let us see about the scales. Scales are hard adhering deposit which is found on the inner walls of the boiler. See here, the black portion is the scale which is formed, which is a hard and adhering deposits on the inner wall of the boiler. They are so adhering to the surface, so firmly adhering to the surface that if I even use hammer and chisel to remove this hard scale, it is difficult to remove. So they have a lot of binding with the metallic part of the boiler and they stick to the inner walls of the boiler. These scales are formed by the salt like calcium sulfate, magnesium hydroxide, calcium bicarbonate, magnesium chloride, calcium silicate and magnesium silicate. Causes of scale formation. What are the major causes of scale formation? We have seen the salt which are responsible for scale formation. There are four major reasons for scale formation. First one is decomposition of calcium bicarbonate. This calcium bicarbonate in low pressure boiler, when we start boiling it, it starts converting itself into calcium carbonate, and which is a precipitate and which deposits on the walls of the boiler. These are not loose slimy precipitate which will float, but it is the precipitate which will go and deposit on the walls of the boiler. Calcium carbonate deposits expelling carbon dioxide. But the same calcium bicarbonate, if it is used in a high pressure boiler water, then it does not cause any scale formation because of high solubility in high pressure boiler, converting calcium carbonate into calcium hydroxide which is soluble. So hence does not cause any problem in high pressure boiler. So calcium bicarbonate forms scales only in low pressure boiler but not in high pressure boiler. Second one, most important one, is the deposition of calcium sulfate. This is the one salt which is responsible for the major trouble in the boilers, and major scale formation is due to calcium sulfate. Is the salt which has a very hard and adhering deposit to the surface, and the property is also reversed. It is highly soluble in cold water and less soluble in hot water. As we start boiling the water, the salt, calcium sulfate, is thrown out of the water, and this precipitate goes and deposits on the walls of the boiler as a hard and adhering deposit. One major salt we have to talk about scale, it is calcium sulfate, which is responsible, and this is the salt which is responsible in any boiler, even in high pressure boilers too. Before that, we'll see the pictures of what is scale really about in real-time view. See, in the first figure, we can see the white deposit, white portion completely, which is the scale formation, and the remaining portion is the pipeline. You can, I think so, you can distinguish it very well. So much of salt deposit choking the pipeline. So we have to change the heating process so that pressure is maintained at the same level. Here you can see in the next view, you can see that the first one, which is a very clear picture with before utilizing any boiling in it. Okay, it's a heater, heating coil, and see once it has been used, what is the level of deposit found in the boiler. So to distinguish, and these are down pictures are first one is even because of corrosion, not only because of deposit, also it started corroding here. And next one, it is purely, you can see the white portion is a scale deposit. Here it is corrosion cum deposits. Okay. Third point, hydrolysis of magnesium salt. Even a small traces of magnesium salt, any type of magnesium salt, generally it converts itself into magnesium hydroxide, which is a soft precipitate and which may get deposited on the walls of the boilers, and these deposits can be removed easily by iron scrapers, by easily it can be removed because it's a soft deposit, but it has another problem. See the equation, magnesium chloride plus water at higher temperature forms magnesium hydroxide precipitate, which is a scale, and it gives 2 hydrogen chloride. So what is hydrogen chloride? It is hydrochloric acid. You know what is when acid comes in contact with metal, what happens? Yeah, it is true. It forms corrosion. So even though magnesium chloride forms a soft scale, it does not matter at all. But even a small traces of magnesium salt may lead to acid formation, and which may lead to corrosion of the boiler part and another trouble in the boilers. So magnesium salt should be avoided in the boiler feed water. So it lead to corrosion of the boiler parts. Then the last fourth one, very important thing, presence of silica. Generally water contains traces of silica particle in it, and this is also another one where we get a hard adhering deposit like calcium sulfate. Calcium and magnesium silicate both forms a hard adhering deposit. Generally it is found in traces quantity. In low pressure boiler, they deposit in the boiler walls. In high pressure boilers, they deposit in the turbine blades. What is the purpose of turbine blade? For the production of electricity. So it is even more worst. Okay, so presence of silica to be avoided. Deposits of silica as well as calcium sulfate forms a very hard adhering deposit, whereas calcium carbonate and magnesium chloride forms a soft deposit which may be easily removed. Disadvantages of scale formations. So what are the disadvantages of scale formation? So as we saw in sludge, it is here also wastage of fuel. There the wastage of fuel is in lower level, but here the wastage of fuel in higher level because heat conduction is stopped, blocked by the deposit inside the boiler. Outside we are boiling with, we are heating the metal container, but inner part is covered with a bad conductor, so heat transfer is not happening properly. So it leads to the more consumption of the fuel. We have to supply more heat so that we can produce the required amount of pressurized steam. So here there is an analysis given in the table telling that if 0.325 mm of the deposit of the salt is there, then it means there is a wastage of 10% of fuel. Your fuel is wasted to 10%. If this we are going to double, almost double it, 0.625, it is 15. See here, when this is doubled to 1.25, 50% there is a wastage of fuel, and here 2.5 it is 80%. Above that it is waste of using that boiler. You can throw that out, buy a new one and start using it. Otherwise there is a huge loss to you in the form of wastage of fuel. Yeah, second one, lowering of efficiency of the boiler. Just like sludge, scale also even deposits on the walls and pipelines and chokes them partially, thus reducing the efficiency of the boiler. Yeah, last very important point, danger of explosion of the boilers. How this may happen? See, when we start boiling the water, when we are supplying heat to the boilers, so once the scales have started forming on it, so we have to supply more heat or more flame so that water is boiling and the steam pressure is maintained, production of steam is maintained. So what happens as we go on increasing the supply of the heat, what happens, the lowermost part of your boiler, which is made up of a metal, starts melting because of overheating. So when it starts melting, what happens, when it starts melting, it starts expanding. Melting means it starts expanding. When it starts expanding, it gives a crack inside the boiler, that is scale which is formed, which is not a conductor, so it starts breaking because of the expansion of the metal part outside. Okay, so what happens, suddenly water gushes into the open up part, that is where the scale is broken up, and that part water start gushing in and it is in direct contact with the boiler. Now it is in direct contact with the metal part, so which is heated quickly. Suddenly what happens, there is a accumulation of steam and it is pressurized. It is actually to say it is over pressurized, which may lead to the, if unnoticed, it may lead to the explosion of the boiler. See, such a huge damage to the boiler. Once the boiler is exploded, the industry itself we have to close it. There is no use of it, or that unit itself we have to completely close it. We should avoid that danger of explosion. Okay, how to remove the scales? Periodically, you can change the boilers and remove the scale. Partially, it can be removed by iron scraping, that is soft scales can be removed by iron scrapers, and you have a brittle hard thing, then you can give a thermal shock to remove that, to cut off that and remove the scales from the boiler. And you may add a certain amount of 10% of hydrochloric acid or 5% of EDTA to remove the calcium carbonate or calcium sulfate salt. For calcium carbonate, it may be HCl, diluted HCl can be used. Okay, without affecting the corrosion of the boiler part, it should be diluted and treated for a small time period and washed quickly. And here 5% of EDTA for this dissolution of calcium sulfate here. It's a temporary method only to reduce the formation of. Yeah, I told about boiler explosion. No? So this is the real site of boiler explosion in an industry. So it is my better advice to anything is under worst condition where we have to supply more fuel for boiler to give you the required steam. That is, it is crossing 50% of fuel, more consumption, then it is wise to stop the unit and go with a new boiler unit, so that you can save people as well as the industry itself. Here in the second picture you can see a photograph of a steam engine. Have you ever seen steam engine? So steam engine is, first it was used for the four-wheeler as a fuel. So here it is the boiler tubes. You can see the boiler tubes. So this steam engine after explosion, how it looked like. So that's a view of the steam engine after explosion. Don't consider explosion as an easy thing. See in the industrial view how bad it is. how terror it looks here. So avoid that. So boiler means it will explode. It doesn't mean that. So we have developed the more technology. That time there was no technology, so that we can see it and can see the health of the boiler, and we have whether we have to continue or to stop. If the boiler efficiency or the fuel efficiency is going down more than by 50%, then we have to stop that unit. To avoid boiler explosion, how to prevent the scales and sludge formation? Is it possible? Yes. What is the cause for scales and sludge? It is because of calcium and magnesium salt. If you are able to remove calcium and magnesium salt from water, then that water will be best for boilers. Or either if we have the soft water to be used in the given area, then the industrial person can be happy, and he can use a soft water which will prevent boiler explosion. If a person is not able to find soft water and he is working in high pressure boiler, then he has to undergo softening process of water and then utilizing in the boiler. If he is working on low pressure boiler, he can go for other alternative, which is a cheaper method. Softening the water and using in the boiler is the costliest method, and this cost may be backed on his end product, and he may not be able to afford it or compete in the market. So we have to go for another alternative. As an engineer, we have to think about any other better solution. If we are able to reduce the problem by 50% also, it is a better solution. Okay, and it should be cheaper in rate. So what we can do, where the problem really lies, when the problem arises actually. When we take the water, salts are dissolved and water looks to be very clear. But as we start boiling the water, the concentration of the salt start increasing in the boiler, and it leads to the increase in concentration leads to the formation of the scales and sludge. So to avoid the formation of scales and sludge, the salt should not reach the saturation point. If you are able to avoid that, then scales and sludge can be prevented in the boiler in a cheaper method. So this method is called periodic blowdown operation. It is not an 100% effective method, but it is a cheaper method which can prolong the life of your boiler from more than 50% of it. Life of the boiler can be increased by 50%. If it comes for 10 years, it can the life can be increased to 15 years too, and that would be affordable for the industrial persons. So how it works, how the periodic blowdown operation works. Let us see the graph. Here you can see the red line. This red line indicates if we are not doing any operation, anything, and we are continuously boiling the water and producing steam. When the salt concentration crosses its saturation point, the scales and sludges are formed because salts are thrown out. After this point of time, the scales and sludges is formed. But when we do periodic blowdown operation, that is explained by a blue line in the graph. So what happens, initially the red and blue line is merging, increase in the salt concentration is the same, and in the periodically in a given period, first what we do blowdown operation. What is periodic blowdown operation? A part of the water from the boiler is removed and fresh water, preheated fresh water is gushed into the boiler, and part of the boiling water is removed. It means salt concentrated water is removed out and preheated fresh water is inserted. It means concentration of the salt inside the boiler drops because of periodic blowdown, because of blowdown operation. And now again there will be a small disturbance for 5 minutes in the boiler in the production of steam, and then it starts continuing it. And now what happens, again we continue to produce steam. So this is again a blue line where the concentration of the salt is increasing. Again in a blowdown operation, what happens, concentration drops drops here, and again when we continue this, So this blue line is continuing falling, and wherever you can see the fall, and there and all we have done periodic blow down operation. That is, we have removed the hot water and we have gushed the fresh preheated water into it, so that salt concentration does not reach the saturation point easily, so that scales and sludge is formed. See the time period, time gap here. Only here the salt is about to be saturated and it is thrown into scales and sludge formation. So you are increasing the time period of that. Hence you are increasing the life of your boilers. So this could be a cheaper method for an entrepreneur, for a new entrepreneur, for a beginner in the industry who cannot afford for softening the water and utilizing it. So he can go with periodic blow down operation, so that he can increase the life of the boiler from a lesser period to a larger period where he can afford it. So this is a simple diagram to explain the blow down operation. Difference between sludge and scale. We have seen about sludges and scale. So what is sludge and scale? Always in differences, first point should be the definition and last point should be the examples. Okay. So first point, what is the definition of sludge and scale? Sludge is loose, slimy precipitate, non-adherent precipitate, and scale is something which is adhering to the surface, hard, thick, adhering to the surface. What are the salt cause? Generally, magnesium salt are responsible for sludge, and here the two important thing, calcium sulfate, silicate, magnesium and calcium silicate, calcium bicarbonate are the cause for the scale formation. So sludges, disadvantages of sludges. So sludges are poor conductor of heat, okay, and decreases the boiler efficiency. Scale, on the other hand, it's a thermal insulator. It's not a poor conductor, it's a thermal insulator. It deposits on the wall and disturbs in the conduction, decreases the boiler efficiency, and any crack developed on the scale may lead to, I have explained, boiler explosion. Okay. Then prevention. How can we prevent the sludge formation and the scale formation? Sludge formation can be prevented by using a soft water or by periodic blow down operation, and scale could be prevented by external treatment. We will be seeing in later classes. Ion exchange method, internal treatment, where we have introduced salt into the boilers. Thank you, children.